Here we shall discuss some properties of bivariate joint distributions. Suppose fxy is the CDF, the joint CDF of a pair of random variables x and y. Then for fixed y, any fixed value of y, fxy is non-decreasing in x. By this I mean, if you take two values x1 and x2, where x1 is less than x2, then fx1y will be less than or equal to fx2y. Pictorially, it is quite easy to see. This is the point x1, y. So f of x1, y is the probability of the rectangle, infinite rectangle to the southwest of that point. Similarly, this is the point x2, y. So fx2y is the total probability of this bigger rectangle. So this probability is extra, and probability being something non-negative, this is greater than or equal to this. Algebraically, this difference is difference of these probabilities. Y less than or equal to y is common to both the things. So it is this probability, and probabilities are always non-negative. Now a similar argument can be given for fixed x. For fixed x, fxy is non-decreasing in y. The proof is of course similar. The next theorem will give us a stronger type of non-decreasing property for bivariate CDFs. Whatever xy you take, real numbers, and whatever ab you take, positive, you will have this thing. Now when you look at it for the first time, it looks very confusing, but actually it is extremely intuitive once you draw the diagram. Look at the pattern. I have fxy minus fx minus a, y is the same. Then I do the similar thing with y, keeping x the same, both have minus. Finally I add a plus term. Now let's draw a diagram. So I have the point x, y. I have the point x, y minus b, this point and this point. So the entire drama is working with these four corners of a rectangle. Now what is fxy? This whole probability. In order to keep track of things, I will label the rectangles as a, b, c and d. So fxy is sum of all these things. From this I am subtracting x minus a y. X minus a y. So I am subtracting this part. So c and d. Then I am further subtracting this part, x, y minus b. X and y minus b. So this part, d and b. And finally I am adding x minus a, y minus b, that is this point, so adding d. So just like inclusion exclusion, you will see PC cancels off, PB cancels off, PD minus PD cancels off, but you have subtracted it twice. So this, and finally you added it. So the only thing that remains is probability of A. Now that's a probability, so it has to be non-negative, hence you have this. This property, by the way, is stronger than the last theorem. So from this you can conclude that once you keep x fixed, fxy will be non-decreasing in y and vice versa. In this problem, fxy is again CDF of some xy. I have taken that b complicated expression, exactly the same thing as we used in the theorem. Now I have taken limit as a and b both go to 0 from the positive direction. Your job is to express this as probability of some very familiar event. That is a very simple event for which this will be the probability. Just think pictorially and you have to come up with the event. That's it.